Welcome, welcome, welcome. Welcome to the Programming Club number 3. And my name's Blades, this is Amberskies, and it's the future. And I really do mean that, of 3D networking. I'm a bit nervous. I'm really a bit nervous about today because we are going to overstep the boundaries, I think, a little bit. We're going to do ECS. I've had no suggestions on which languages you want or anything like that, so fair enough. Let's get ourselves a Linux system. May as well. It's easier to work with. ECS, what does it mean to a lot of people? Well, let's explore that at the same time, shall we? I've got a horrible feeling that a lot of people might misunderstand what it is, and I think that's Unity's fault, but anyway. We'll see. Here we go. We've got a computer starting up. Nice. There we are. What can we do with this then? Does anybody know my password? I'm not sure if I do. Do I? Yes. Good. Excellent. We've got Linux. Nice one. Oh, we've got a choice of languages that we can do this in, but I think we'll be using C++ for some reason. I'll use this one again. Why not? Doesn't really matter, does it? Not for this code, it doesn't. It doesn't matter where I put it. It's independent code. Can go into any system you want. It's not a problem. So what are we going to do, or how are we going to make it? ECS. It's going to go in here, isn't it? Alright. New folder. I'm just going to call it ECS. That'll do. Okay, Miss Chief, what do you know about ECS? Oh, God. How am I going to explain this? Yeah. Once upon a time, we had entities containing components. Okay, and the components triggered, I'll say triggered or triggered the code. Now that meant there was a logic component. There's some logic in here, and the entities usually were classes. So that would be a class for your whole entity, and this would be some kind of logic that you wanted to operate upon that entity. And that was the entity component system. But it was never meant to be. That's what it got interpreted as and misunderstood as. If you go back and look at the original specifications for an entity component system, you won't see that at all. What you will see is something very different. And the reason why this happened, by the way, is because of C++. And C++ is to blame for that. So let's try again. Let's have an entity. And an entity is a list of components. Now this is easy for me because that is equivalent to a VAO. Now, a vertex array object from OpenGL is exactly the same thing. In fact, the VAO under this system would be called an entity. That's interesting. That's very interesting. So that you've got to have that kind of idea that it's just a list of components. It isn't, there's no logic in there. It's just a list of components. A list. Okay. So what does that make the components? Data. Data. Nothing, and nothing else in there, just data. So your components are now data, and data only. Your entities are a list of components, so how do these get used? How it works is that you will have a system. Yes, there's a third part to it. That's why it's ECS. We haven't talked about this little baby here. The system, whatever system you write, our little black box, we'll call that a system. It can be a system for anything. Movement, physics, specific part of physics, collision detection. There's lots and lots of systems you can make. Animation. Yeah. So what this would take in is a component. So I'll put a component as a little box, like that, a C. And there's your entity, E, which has this component acted upon there. And this component of data would be done by that. But that component may be in other entities. So you'd have that, and it may take in more than one component. The movement component may take in an input component and a position component. Things like that. I mean, components are just going to be little blocks of data. They're not going to be huge, not going to be fantastic, they're not going to do much. But now I've got a problem because it's C++. So we now know what we're dealing with. We've tried again, and that's what we have. But in C++, it's heavily static type defined. Now what does that mean? We've never talked about it before. What it means is when you compile a C++ program, at runtime all the types are known. But hold on a minute. I haven't typed anything in our ECS system. So the types are unknown. Oh. So we're going to need something completely different. We are going to have to need a dynamic system for typing. So let's start right at the beginning. So how can we create a world that we can interact with? And there's only one way to answer that question, and that's with another question. What constitutes something in our world? And this is where the ECS system comes in, because this will define something that's within our world so that we can interact with other things in our world. So the answer is ECS, and it's really gets confused because of the old way of thinking, and the old way of thinking of entities with components, and component methods and things like that. So we've got an entity now which is a list of components. We've got a component which is just raw data, and we have systems which act on components, but only certain components. What do we gain from it? What does this mean? If we can get past the heavily static type defined system, what do we gain? Well, this is it, folks. This is what we gain. I've got a list here somewhere, so let's have a look at my notes. Okay. Why do we want to build an ECS system? What's it all about, Blades? Come on. Well, we get a pen. Turn it the other way up. That helps. Thank you. We get easy. Whoops, still in the wrong mode. Very easy component. This is important. Interaction. And that is actually our goal. That answers the first question. How can we create a world that can be interacted with? And that's it. Easy component interaction. What else do we get? Oh God, yeah. Easy loads and save games. Well, all our data's in components. Just dump them out to a file. Load them up from a file. There's all your data for the game. So that's all you have to do, is just load or save your components. Wow. So these are dynamic. We can load and save them. And the game has no idea what they're going to be. This is fantastic. And what else have we done? We have separated logic and data. Total separation of logic and data. So in the old days it was an entity with its components. All the logic and data was held in the two, but they combined the two into like a class. So all your logic and data got mixed in there. This way we don't have any clash between logic and data, because the entity is a list, just a list of components, and the components are just data. So there's a complete separation now between the logic and the data, because the logic is now in the system. All the system, that third part that got ignored, is now your logic area. So we've got that. We've got logic and data separation. That is fantastic, because it means you can go away, write your logic, decide what data you need, and then make a component for that data. Does that sound good? Does that sound really good? It does to me. Alright, Something that I've been avoiding all the way through the series because I don't think it's really worth doing, but we now get easy multi-threading. So we can act on multiple systems. Oh God, what happened there? I got a lag. So we can run multiple systems at the same time, as long as they are acting on different components. So you can process multiple systems at one time using threading. Ooh, that's interesting. And the best bit of all, efficiency. Only updates what's needed. Yeah. So you can efficiently now run a system because it will only update what is needed. It will not have to worry about the entity. It won't have to worry about its results. It won't have to modify other systems. Each system can stand alone and modify the data as it sees fit. And you can run multiple systems at once. This is sounding too good to be true. What's the catch? Yes, here's the catch. We have to... This is the con. These are all the pros. This is the con. We have to create... that didn't work too well. Never mind. We have to create a dynamic runtime component system. Which means we have to allocate and deallocate memory on the fly. At the heart of that. Because on a static system, it would have fixed memory. And as the data may not fit into that memory, that could cause problems. So we need to be able to, on the fly, create and destroy memory, free it back up to the system. So that's where we're left. We're left on this horrid precipice of doom, because C++ doesn't work that way. Or does it? Or can it? Well, you could. You could use macros. Macros would... Oh no, that would just be a nightmare. What we could do is use... I've got a note down here about it somewhere. Sure I have. Is it right at the end? Aha! Let's look this up, shall we? The curiously recurring template pattern. Let's see if we can get a wiki on that. Here we go. Right. It's an idiom in C++ in which a class X derives from a class template instantiation using X itself as the template argument. More generally, it's known as F-bound polymorphism. Yes. And we can use that to generate a dynamic typing and memory allocation and destruction system. Okay, so it looks something like template class T, class derived, blah, blah, blah. Then you've got your static polymorphism, which we're trying to avoid. And we want to go for more dynamic. And it's got all the examples and polymorphic chaining and stuff like that here. So this is the kind of territory that we are going into. So it is the edge of a precipice. One issue with it is that without using a general base class like shape, derived classes cannot be stored homogeneously as one. Basically that means the base class is a unique type. For this reason, it is more common to inherit from the shared base class with a no, we're not going to do that. This is the pitfall, but the pitfall is what we want, because the base class is a unique type. And remember what I said? We wanted to make a dynamic typed component. And the pitfall is our entry point to doing that. Cool, huh? Very cool. So we're going to actually use the curiously recurring template pattern to and its pitfall to make us a dynamic dynamic at runtime component system. There we go. So let's put that down on our thing here, so that I've got something to refer back to. So we shall use just for reference purposes, and you can look it up yourself, there's a wiki on it. It's the Curie, oh god, this is going to be fun, Owsley recurring. I mean, spelling's probably wrong, but I don't care. Now, I know that a lot of people who are watching this probably have never done templates in C++, and that's fine. This will be your first journey into it, and you've got a wiki as backup to make sure that I do it right. Let's just pray I do, because it's going to be standalone, which means you can fit this into any current system you have, whether it's a 2D engine, game engine, a 3D game engine, a console adventure program, whatever you want. But we need this so that we can have interaction. And it creates dynamic interaction, because we can have an interaction that creates another component. When you think about it, data interacting with data could create an offshoot of data. Yeah, now you know why I need it dynamic. How are we going to do this? Let's just get on with it and hope for the best, shall we? Yeah. I hope I've edited my notes enough. I think I have. It's got lots and lots of scribblings on it. Okay. So where shall we start? With a file. We are going to start with what's going to be the most complex thing I've ever written, and I've got to write it in a simple way. And it's going to be ECS component. Nothing too difficult so far, thank God. Dot HPP, because we're using that standard. We don't need the welcome screen. And now the fun starts. When did I create this? I think I did it yesterday. What's today? 30th. Yeah, I wrote all this up yesterday, so I'll use yesterday's. And now we see whether I can copy and paste into a virtual machine. Yes, I can. Good. I did set that up properly then. Hash pragma once. Thank God for guide notes. In this case, because it really is difficult. So my script, I actually wrote a script and I've been through it 2 times to make sure it's correct. I've never actually written the final program, so let's hope it does work out. I hope it does anyway. So, what kind of things are we going to include? Let's do those first. Let's get those out of the way with. We'll have core and common. I think that's obvious. Oh, why did it just do that one? I don't know. Common. There we go. COMMON. Okay. Funny. I don't like this IntelliSense system. CORE/common tab. Alright, I'm just ignore it then. Include. Data structures. And we're going to need the array, I think. I think we've got something wrong in our VS Code here. Source asterisk asterisk. No, I haven't. Okay. I'm also going to define what we're going to define a null entity handle, just so it reads properly. Because we're going to have to use a handle system, as our components aren't going to know much about the entity at all. In fact, nothing except for this handle. I'll make that null pointer. Let's put the main struct in, then it's not a class. We don't need a class. And this is just going to be our base ECS component. That's going to be our main struct. I need it in here because we're going to put something in between. Alright, so that's going to be our base. But here, I need to forward declare that we're going to do it. So it's a struct, and it's a base ECS. I told you this is going to be complicated component. So I'm just forwardly declaring it because what I put next will require it, and this is our type defs. So our first type define, our type definition is going to be void star. We'll have one of those, and that's going to be the entity handle. got to be a void star, remember, because we don't know what it's going to be. Yeah, this is how much fun we're going to have with this one. This is going to be constructed on the base that we don't know what anything's going to be. So next type def. This one's going to be a bit more awkward. I need a pointer. So it's going to be a uint32 no matter what I do. But you can't do that, so it's a pointer. So it's not uint pointer, it's the pointer has to go on the right side, so we need brackets to make sure it goes with the right side. I'm going to put a pointer to an ECS. Let's call it component. Create. And it's a function. So ECS component create function, that's going to have something. I'll call it A for now. I don't know what to call it yet because we haven't done it. That's a semicolon. And type def. Yeah, you can see how this is working out already. And I'm going to need another void, aren't I? So it's a void star, but the star has to be in the right place again. So I'll do it this way. ECS component. And we're going to call this our free function. And again, I ain't got a clue what it's going to be, so I'll call it B. There you go. Don't know what it's going to be yet. So A and B are going to be replaced by something, whatever the type def is. But when we use that, we are going to get our type def. When we use this, we're going to get our type def. That's the whole point of this. How you build this in C++ is a bit awkward, and that's where this template thing comes in handy. So our basic struct. We are going to need a CPP file, aren't we? Yep, we are. So we are going to need a static. Our basic struct is going to do one thing and one thing only, I think. uint. We'll call it next ID. Yeah? Yeah. We'll make it into a function. Which gives us a new file. And that's going to be ECS component.cpp. That's going to... Better save this out now. That's going to hold that. And it's going to hold that file. And all we're going to do here is set up a variable. Oh no, we're not going to include, aren't we? Sorry. Hash include. And it's going to be ECS component HPP. Oh, good, it knows where that one is. Thank God for that. We're going to need a static variable of some kind. uint32, I think I'm using virtually everywhere on this. So component ID. There we go, that's just floating out there, why not? Oh, it doesn't know where ECS component.hpp is. What? No, it's just plain silly buggers, isn't it? Yeah. Right, let's have our uint32 base ECS component. Yep, colon. Next ID. You might notice there's no constructor or destructor. It'll do that itself. We're not going to bother with it. And all we're going to do is return component ID. And then add one to it. So increments. Right, so that's that done. So we have our ID. Incomplete type is not allowed. What is incomplete about it? Oh dear, did I mess that up? Base ECS component, yeah. Yeah, I messed it up. Yeah, that's correct. Component ID, uint32, uint32. Yes, you work, stop it. Oh god, how do I get this to work? Copy you. Make sure I spelt everything right. Ah, capitals. Right. There, now it works. Excellent. Fantastic. So our little function works. All it does is return a component ID which starts at 0 and increases. uint32 can hold a lot of numbers, so that's a heck of a lot of components we can do before it overflows. I think I'll go with that then. That's all it's going to do, so that's it. That's that done. Now, where shall we start? I'll start with an example of what we're aiming for. So, this is the example code. And this will dynamically add an ID. No, let's not do that. How's about the curiously, let's name it, the curiously recurring, is it RECC? Recur. No, it's REC. Double R. Recurring. God, I'm arguing with myself on how to spell that one word. I don't believe it. Template. Pattern. So we're going to use that. And that looks like this. So you would write something like a struct, if you wanted it to be a struct, that is. We'll have a test component, because it's not going to do anything. And all it will do is inherit publicly from our ECS component, which I believe we don't have yet. And it would just have test component in there. I can't actually see those. No, yes I can now. Angle brackets. That's how we do a template. So a template in C++ has angle brackets. In this one, the type, the template type, is going to be our own test component. So this will be typed to itself. And that's how you dynamically do it. So you're repeating this into the type for the ECS component to deal with, and the ECS component now has to type it up, make sure it becomes a type. That's why we've got all of this up here. How on earth are we going to do that? We're going to need an ECS component, aren't we? That might help. So let's first of all make our... Do you want to make the component first, or do we want to complete the base component? I think the base component's complete. Yeah. No, it's not. The only other thing we're going to need in here is the handle. So we're going to have an ID for the component. So component will be number 1, 2, 3, 4, 5, to whatever. But we'll also need to know not a lot about the entity, but we'll need at least a handle to it. And that handle is going to be a pointer. So a pointer to which entity we belong to. Okay, I think we can do that. So we would need an entity handle because we've type defed it here. So we can have that now as a type. And we're just going to call it entity. And why not? And that's going to equal, well, null entity handle to start. Oh, it's done it again. Null entity handle. Thank you. So that's our setup for the base ECS component. And everything else should inherit from that. And they will inherit an ID and a pointer to which entity they are handled by, or handled to, depending on which way around we're looking at it. Okay, so that's our base ECS component complete. Lovely. We've got red squigglies on A and B, which is absolutely fantastic because they'll probably be the last things that happen. What do we need next? We need that ECS component, don't we? And it's a type def. Sorry, a template. So it started with the word template. Now, templates always take in a T or type. Normally, like that. That's how you would normally see a template written. In this case, it's type name. And that's just type name. Type. Because we're going to use it as a type name, which is fine. We're okay with that so far. So our template will accept our new type name, because we're creating it in here, into the template. That gets transferred in. That's good. And the struct is going to look something like ECS component. And then it's colon. And then it's public. Inherit. How complicated can we get? Base. ECS component. So this is now our declaration. Tab. This is our declaration. Remember, in C++, the header file takes all the declarations, and the CPP file takes all the definitions. Well, in this case, we're doing all the declarations and all the definitions in the header file. So that's why I'm marking it as a declaration, so I remember. And if it's a declaration, we can do that. And semicolon, yeah. That's right. Now what we're going to need in here. We can have a static, let's build this up, static const, and it's going to be that ID, isn't it? So it's a uint32. uint32. And we'll just call it ID. It's going to be, the next one will be a static const. These are the variables. Public variables at that. This will be a size t because we won't know what the heck it is. And that's just going to be, we'll call it size. Because we can. Alright. What else are we going to need? We're going to need right, so let's label this up. Otherwise I'm going to get lost. Sorry about this, but I'm going to start using comments. This gives us an automatic ID. Okay, provided to us by that there from the base ECS component. That comes in through the inheritance. Okay. You've seen me use inheritance on abstract classes. It's the same kind of thing, where you inherit the properties of the abstract class. Well, in this case, we are inheriting the properties of a struct. So it's simpler, really, for the inheritance. But it's this template thing that's going to get very complicated. This is going to gives us the size. This is important. Size in bytes. So we can allocate memory. Oh dear. We want to allocate memory, do we? Alright. Yeah. How are we going to allocate memory? Well, to assign memory, we will create a function. We will use this one here, the create function. But that's a type. Yeah, we are using a function pointer as a type. So we'll make it a const. So we don't want to change it after we've got it. We'll just call it though, create function. That'll do, won't it? Yeah. That will assign memory. Okay, we can do another one as well. So static const. The other one is the free function. We obviously know what that does, but again, it's a function pointer. And that function will, free. Yeah, we'll just call it free function. The reason why I'm putting it all in capitals is because of the const. So all constants I always put in capitals. And that's going to free up memory. There we go. That's it. I mean, that's all we really need to do for the component. That's its functionality. So that's going to take all the functionality of the component and how to set it up, give it an ID, find its size, create and free up memory as required. Oh, how are we going to do that? Okay. This is where it gets a little bit confusing because we've got that declaration. How are we going to do all of our definitions? So each definition is in itself a template, and that's why it's confusing as hell. Yeah, I know. It's amazing. It's amazing what you can do with C++ templating. It's the most powerful part of the system. I still got that music playing in the background. Can we just switch that off? Thank you. I've got wobbly lines below ECS component create. It's undefined. No, it's not. It's A. Oh, yes, it is. It's undefined. We'll have to define it. Okay, what can we define it as? Let's have a look. Should we define those two first before we try and use them? We can define them as ECS component create and ECS component free, couldn't we? God, that's going to be ugly. Well, it's giving me red squigglies, and I've now got red squigglies that match up, so really I think I should write the code. Okay, let's see if we can. Something just crashed out there. I think one of the cats has hit something. Which ones are we going to use for that? We are going to use... yeah. Two functions. Right, so it's easier. uint32 will need two functions, because these are function pointers. So let's create a function. It'll be uint32. I'm going to call it, I can call it anything I want. ECS component create, to keep it within the naming conventions. Oh, wait a minute, we'll have to template it, won't we? Okay, we'll template it. We'll take in a component of some kind. Hopefully that, yeah, it's going to go red, isn't it? Because we haven't got them. Let's see what happens. Can I do this yet? Right, I'm going to use the standard array, but it'll look different because I've got different definitions of arrays in there. It's got a wrapper on it. So this isn't C++, this one. This is actually a wrapper. So that's array. Something that we made up here. I'll show you. It's in common. No, it's in here. Peak definition. There you go. Array is a standard vector. Yeah. So if you don't know what I've just typed standard : vector. So if you want to type it in a long format, you can, but please include vector up here as well. So that's std vector. I thought that's a good idea to let you know what it means. So it takes in a uint8. Why a uint8? Because this is going to be the address in memory. What else will we need? The entity handle. Entity, we'll call that. Why not? Doesn't matter. I'll need the base ECS component, because that's the base ECS component, and we're going to need it as a pointer. I'll just call it component, comp. Right, so that goes there. And that means, if I'm right, that that is our A. I think it is. Let's take it out and find out. I think that's our A. There. It has to match. Wow, what a line. Okay, that's now been defined. Still getting red squigglies. He's still not happy with us. It's because of that component bit. So this has to create the memory. Let me just check something. I think I might have done something wrong here. Make sure that is correct. It's array, uint, and memory, yeah. The entity, but yeah, that has to match this, or it can't pick it up. So it's, the compiler needs to have something that's the same, as it were, to hook them together. And it's a template of component, well, templating a component, which is fine. It doesn't matter. We could template it as T if you wanted me to, but I'm not going to. I'm going to give it a name. So, uint 32. I'll have an index. Yeah, we'll have an index. That's going to equal memory dot size. So whatever the size of that memory unit there is, we'll need to know that. We will then have to resize it. This is ridiculous. I'm glad this all gets done automatically for you. We will resize it, index plus component. Whatever we pass in, and that will be colon size. I think it's going to flag that, as it doesn't know yet. Oh, it doesn't. It's going to accept it. Wow. Seriously? Okay. Right, so our component, we shall have a pointer component. And now we're going to do something very, very naughty, and something that you really need to watch this video for. This will educate so many people in what can be done with C++. New component. You'd expect that, wouldn't you? And then we are going to cast comp. But we need to cast it to component star. Yeah? So, put some brackets here. So it will be capital C now. Component star. Okay, so we're casting it to that so it can be a component. From a base component, it will become a component. And to make it all work, we have to dereference it. Yeah. Ain't that just fun? Oh, but there's a problem. We've now got a new command. But that's just going to dynamically put this straight into memory wherever it decides to put it into memory. Well, C++ new is a function. It is not just a command word. It actually has brackets. Yeah. and it doesn't show up. Great. So IntelliSense doesn't even know it's got brackets, but it has. It's C++, it's a function. So we're going to take the new command and tell it to use our memory. So that's the address of memory, and we'll have that at index. There you go. I bet you never knew that. And that is the most complicated line I'm ever going to write. Ever. Because it's come to that because of the way C++ works. That is how we calculate the size and make new use our piece of memory instead of using malloc and putting our component into that memory, which is the correct size because it's going to be given here. We're not totally happy with this because it's undefined, but we'll get there. We'll get there. Okay, what's left to do now? We have to get that to the entity, don't we? So component will have an entity attached to it, and that's going to be entity. There we go. Lovely. So that entity handle will now be assigned to our component's entity thing. That one there. Because it's a base ECS component. So we've just got to add that in there. And we can return a uint32. We can return index. Which is the memory size. Nice. Where's that going to be returned to? I think that gets returned to somewhere here. So that's the ID. Well, it'll filter through to there because that's base yeah. God, this is complicated. Yes, it will be recorded as the size in memory that we have allocated for our component. That will be filtered back into our component, whichever component it is. We don't know yet. We have to do the same for B, but it's a lot simpler. Thank God. We have to free up the memory as well, and we called it void, didn't we? Yeah, we made it a void. So it's exactly, may as well use a template, and it's component again because we don't know which one, component, any component will do, and it's void, yeah, we can just have ECS component free. It's good enough name as any. Why did I leave a gap there? It's a function. That's all it is, it's a function. And now we have to write this one out. So it's just going to be the base ECS. Base, this has got all the information in. Base ECS component, and we'll just take the address of the, well, we'll just take the address of it. Full stop. Yep, that'll do nicely. Did I put a Dewberry on this one by accident? No, I didn't. Good. So we need to copy that. And that's B. Well, that looks a lot easier, doesn't it? It's easy to free memory up because we've already got all the information. We've already worked out all the information and we've returned the size here. So it's in B base ECS component, it has the size. How does this go now? It's only a couple of lines, isn't it? So we have to first of all change that over to our component. So we'll have to cast it over, because we don't know what it is. Component. I'm going to spell it wrong now, aren't I? Star component. And that's going to equal, we've got to cast it. This is going to be awkward. No, because we can do it from that way. Component star, and then it's just comp. Yeah. Does that work? Yeah, that'll cast it over. And then we're going to do the easiest thing in the world. And it's the only time when you're going to ever be able to legally do this in C++, and it's correct. We're going to do component, component, and it's going to call its destructor, or the destructor of the component that's passed in, should I say. Because we don't know what that is yet. And it's the only time when you can really do that legally. That squiggly doesn't look like a squiggly to me. Did I squiggle it right? Yeah, that's a squiggly. Yeah, it is. It's an up and downy thingy, one of them. So that's the destructor we are calling. So that's legal, he says. Take that bit. No, we'll be fine. So we don't know what the components are. Right, okay. Great. Why? Because I've missed something out, I think. Yes, I have done those wrong. Those are type names. That's it. We've got it now. It's going to work. Please say. Those are type names. Come on, get rid of these squiggles up here. What's wrong with you now? Function returning function is not allowed. Which part? This is the problem with C++. Function returning function is not allowed. Yes, it is. Return index. That's a void. That's a uint32. We're not returning a function. We're using a function. Just wondering if it matters where these ampersands go. Base component, comp. I can't see anything wrong with that at this point in time, but let's just check our templating. Template type name, yeah. Looks good to me. Okay. Make sure the destructor is called. I think that's a good way of putting that. Still thinking that's okay. I don't know if it's because it can't work out the logic for it. Because the logic for this is absolutely crackers. So these have come up. These are working all right now. So those have stopped being underlined in red. So we've now got these two types working, but it's still saying blah, 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 blah. It's not error type. Type def error type. Have we missed something here, like a type? We don't need to type into there. It's talking rubbish. We've got our base ECS. Right, our base ECS component is being used there. Yeah, that's fine. We forward declared it. Entity handle is used there. That's done first. Do I need to put these the way up or something? Free before create? No. Oh well. I'll let that squiggle go. I've got another squiggle over here somewhere. Can anybody see the other squiggle? It says it's on this line. Yeah, because we haven't finished it. We never finished the test code, did we? Let's finish our test code. So this example, you'd have something like float x semicolon float y semicolon etc. And we also get ID plus memory control from templates. Okay. It's a struct, so please put semicolon at the end. So our components are going to look something like this. We're going to get our ID and memory control free. Isn't that nice? If I can work it out, that is. Right, so that's got rid of that bottom one. There's only that one that's complaining at this point, so that's good, I suppose. Or it could be bad. Right, let's now declare. No, we've done the declaration. Let's now define all of our bits here. Okay, so ID, size, create function, and free function. Okie dokies. Each of these is going to be a template of type. Type name type. Okay, type name T, type name component, yeah. Type name component, yeah. Alright, let's clear out some space here. So this is all going to now be definitions. Instead of using a CPP file. I don't want the definitions in the CPP file because when you see them, you'll know why I don't want them there. Okay. Because they look terrible. Right, so we'll put our definitions in here. These are the definitions for ECS component. So we've got those declarations here. Definitions for just bring that back a bit. There we go. Definitions for ECS component. What's the first one we've got? ID. Alright. Template. And then it's type name. We'll have T. Because that's a standard way of doing a template for some reason these days. No idea why. There we go. There's our template of type T. All we have to do is write the function. So it's going to be const it's going to be part of the ECS component, so it's const uint 32. Oh, yummy, yummy, this is going to be fun. Const uint 32. Then we can put, it has to be part of ECS component. That's a definite. And that's going to be part of T, or type T. Yeah, that's right. So then it's : ID, and that means we can now do the definition. And it's base ECS component : next. So it's just a call, next ID. That's it. That's all we need. That's the definition. All we have to do then is spell things right, like const. uint32, there's nothing wrong with that. Don't be stupid, computer. What's wrong with a uint32? ID's a uint32. I'm sure it is. Yes, it is. Argument list of variable template uint32 is missing. No, it's not. How's it suddenly become missing? What's just happened here? Oh, it's taking the Michael. Let me just check this line. T goes in there. Yeah. ID. Base ECS component. Next ID, please. And we return that next ID back in. Yes. Good. Right. I'm happy with that. Let's do a template. Have I missed out a semicolon somewhere? No. Type, name, T again. Doesn't matter what it is, just T will do. This is going to be for size, which is const size T size. Yeah. That's just going to be the same, innit, for all of them. And then it's size. And how do we get the size? Well, it's actually quite simple. It's size of T. Whatever the type is. Size of the type. Just like you do the size of a float or size of a int to get its size. You can do a size of a T, a type name T. And so that should work. Excellent. And I've done it again. I can't type const for some reason. Now it's going to tell me that size T doesn't exist. Because it's stupid. It's doing it just to be awkward. You see, uint comes back. Now we don't have size T. So IntelliSense is slightly going mental at what I'm doing. Let's do the next one. This was create function, wasn't it? And it's just a const thing. Yeah. Okay. Let me just put the template in first. And it's a const. Oh god, it's a const, one of them. This is now a type. Its create function is a type, because that's what we've done with it. And then we're going to need the ECS component part. That's our type. And its create function. Open brackets. And the create function is there. There we go. And all we do is give it type T. Pass it on. There we go. That'll do nicely. So it's create function, ECS component create type T. Whatever T is the component that we're dealing with. That's that one. Let's do template. Type name. Getting used to doing these is horrendous, but it's wise to do it. So we have, that's our create function. Our free function is a type. Specified it as a type. Then we've got this thing again, because that's it. It's a member of that. Then we've got free function. And then we have ECS component free, which we've just written up here. There. And it's going to need a component type, so that goes in there. That goes to a T. That goes to a semicolon. All done. Holy cow. Right, we still have errors in here, which I don't know why. There we go, one just clicked off. I think it's just being an idiot about this one. Function returning function is not allowed. We're returning that. That's the return type, is a uint32. Ah. You don't normally put... Eek. Come on, what is it? What is it? What is it? What's wrong with this? Alright, let's check I've done it right. We have to forward declare. So that's correct. We then type def. Entity handle, function, create and free functions, which we can call anything we want. I wonder if it's the call signature not matching up. That's all matched up there. It's got to match up on this signature. So I'm just wondering if it's messing its signature up. Have I spelt it wrong? No, I have no idea why it's saying that. Because that is the function. It's a pointer to a function. It's a pointer to the create function, which is here. Maybe it's the ordering of things. What I'm going to try and do is a build now and see what happens. It might just crash. I don't know. So it's Control B, is it? Yeah, it's picking it up as an error. So I'm going to have to work out why. Did you mean... yeah. That's what I'm thinking. It's picking up both of them. Does not name a type. Should do. I think we've got a problem here. Why does it need to name that? Okay. Does our ECS component need to be below these? Could be. I think this might be an ordering problem. Never mind. Okay, any help in chat? If anybody can help me with this, I would be absolutely grateful. I know the error's true now, so... it's a type. Have I done something stupid here? Let's just reference my notes. ECS component, create function. The only time I use it is in here in my notes. But this is correct up to a certain point. I think I'm going to have to change something. Damn it. I really wanted that to build. Base ECS comp. I think I've got it wrong. I'm going to have to go back through it. Because that's the function that it points to. And I don't think it's handling this pointer very well. The star, I think it's ignoring that star. Damn it. It's not a function name. And at the moment, the compiler's looking at that as a function name, and it isn't. No, I'm not going to guess. I'm going to sit down with the instruction booklet and look it up, because this all works except for 2 lines, 25 and 26. So those 2 lines there don't work. And for some reason it keeps flashing up different errors all the time, and I wish it wouldn't. So those 2 lines don't work. And I need them to work. I mean, I can't really do too much with ordering of stuff, but I mean, I can try, I suppose. Nope, can't see it. But hopefully you can work out that from this, when we do test component, ECS component, the test component itself is sent in. So that's what all these T's are. So it gains all of these abilities. And that's the whole point of this. And the component is obviously then passed through all of this lot to create. And when it's needed, free will happen. So it creates itself here. But for some reason, it's not picking up that that's a pointer. Type def error type. Interesting. Very interesting. But there you go. That's the basis of the well, not the ECS system, but the C out of the ECS system. So in the next episode, I'm hoping, obviously, to get this part working, which I find very interesting that it's not. I mean, it is complicated, but when you look at it properly, it isn't. All we're doing is giving our test component abilities and running those abilities. I mean, it's not hard really to understand once you have a look at the example code, which is why I put it in. Because obviously the example code shows that the test component itself, once it passes itself in, inherits all of the abilities of our component and a base, well, not the component, but the base component here. The ECS component and the base component. So it gets an ID, it gets a handle to the entity, it gets everything you want. It gets create function, a free function, an ID, and a size. And then for some reason, see, this part's working. and yet up above it isn't. And that is what's a little bit dodgy, I think. So that's up to me to sort out. I don't think anybody's going to be able to answer that one straight off on the chat, because, I mean, I can't answer it straight off without looking it up in the books. And that's what my job is, so there you go. It's my job to find out the answer to these specific problems. So, entity component system. I think I will go and hunt through my books and find out what the answer is. And then I might just look through here and make sure we're using the right one. I haven't put a C standard or a C++ standard in here, have I? Nope. That build is just going through like that. Oh. Okay. So I might have to adjust tasks.json and specify the C++ type year for compilation, because I don't know which one it's using at the moment. Right, that means I've got to do that first. So, enjoy yourselves. There are all of these languages to choose from, and yes, I'm quite happy to do anything you want in any of those languages. The rest this week is ECS, the Entity Component System, properly done in a dynamic way, and it will be working, I hope. Thursday, I'm going to have a bit more of a look at Node.js, I think. Saturday, we are doing beginners, learning like a beginner's renderer for 3D. And Sunday is sailing, so yes. I think I've got my work cut out here. I think I've got a really good problem here, and I'm going to enjoy solving it. So I'm going to go hop off and do that. Yes. Any questions? Any comments or anything else? If you are looking at this from YouTube, use the comments below. Otherwise, just give me a quick nod in chat right now, and I will sort out whatever's going on here, if you know what's going on here. Otherwise, we're just going to have fun. Take care, people, and you lot have fun.